Okay, so welcome to Introduction to Python for Beginners. This is an introductory course, free for all of you guys, and I will try to teach you Python. So, what is Python and why you should learn it? So, Python is one of the world's most used and most popular programming languages. Using Python, you can do web development, especially backend. You can do data science and data analysis, machine learning, deep learning, and in general, anything that has to do with artificial intelligence. It's a very powerful tool that you need to know. And in this tutorial, we will learn about variables, input and output, mathematical operations, comparison operations, logic operations, functions, loops, classes, and complex data types as lists, dictionaries, and tuples. While we download Anaconda, let's go through where we will write code for Python. You have a lot of solutions. You can even use a very simple notepad in your computer. But I suggest that you use Visual Studio Code. I have a link here, you just download it. It's pretty straightforward. You can also use an IDE like PyCharm, where you can do more complex stuff with Python. PyCharm is especially created for Python. But for this tutorial, we're gonna be using Google Colab. This tutorial is all about learning the simple and basic stuff about Python. I do not want to mess up everything with using editors, doing setups, solving problems. I want you to go straight to writing code. And Google Colab is a great option. So please go to Google Colab, and I will also supply you with a file called Notebook where you can load things. But the basic idea is that you go to Google Colab, you load the file and you put a new notebook, and boom, you have created a Google Colab notebook where you can run Python code very fast and very easily. So this is a cell where you can write your code, as you can see. And then there is a text file. It says code and text, and you can use text to write some stuff here. Okay, so when you write text on Google Colab, you do not run executable stuff. If you want to write Python, you need to write it into a code cell. Okay, not in a text cell. So this just for for this tutorial, that's how it's gonna go. We are gonna use Google Colab, but you are free to use Visual Studio Code or PyCharm. But you will have to see a little bit of more tutorials, to get this all set up and running. Python was first released in 1991 by Van Ross, and he released like this version. Then we had Python 1 3 years later, where we have lambdas, map filter, reduce. These are stuff that we're going to see in the advanced course that I will be dropping very soon in the next 2 or 3 months. Then in 2000 we got a Python 2 that introduced list comprehensions and garbage collection. And then 2008, the version of Python that we are gonna be using and we are gonna be learning is Python 3. And really, after this point, Python 3 started to go forward. And Python 2 stopped being updated and, fixed in 2020. So we're gonna be all about Python 3. So this is the first solution. The second one is to use a package like Anaconda, and this is my preferred method. Go here and download Anaconda, and this applies also to every one of you. So you go here and download Anaconda. What Anaconda does is that it can handle multiple libraries, and you can use different versions of Python and, change between versions of Python very easily. Anaconda is the go-to tool if you want to do complex things with Python. Use different versions, use a lot of libraries. I really recommend to start off with Anaconda, and it solves a lot of problems that may arise from the typical download that you would do with just the simple Python website. I have already installed Anaconda, but let's see what you would do if you wanted to install Anaconda. So you open up the package installer, you agree with the terms, specify the users, specify the position, go next. And what I want you really to pay attention to, I really want you to add Anaconda 3 to my path variable and also register Anaconda 3 as the default Python version. that it's going to be used by Visual Studio Code or PyCharm, and you click install. I won't do that so I do not mess my local environment. But this is how you install Python and Anaconda locally. Okay, so let's see how you can install Python. You have two main avenues for this. The first one is to go to python.org in the downloads section and go here and download the stable version, the 3.11.5. Maybe you can download another version, it's up to you, but you can just click this button and download it, install it. I have already installed Python in my computer, but let's go through with this simple installation. So what you want to do is to add python.exe to path if you are on Windows. If you are on Mac, you probably have Python 2 on your computer pre-installed. I will probably have a tutorial for Mac as well, but for Windows users, you want to add path.exe and you want to click install now and you are good to go. So the first thing that we're going to be learning about is variables. What is a variable? A variable is a data structure, or let's say something that you can use to store information. You can store numbers, letters, logical values, even functions and objects and dictionaries and whatever you want. You can pretty much store everything in a variable. So simple variable types. We have an integer. An integer is just a number with no decimal points. Then we have a float number, which is a number with decimal points. Then we got strings. What is a string? It's you can think of it like text, and you use double or single question marks. I don't know how is this called. Notation marks. I really don't know what's called in English. Sorry, I'm not a native speaker, but this is a string. And even 7 here, yes, you will say it's a number, but you got those double strings here. So that denotes that it is a string. And then we got booleans, which is true or false. So you can do logical operations with booleans. And finally, we got the non-type. The non-type is just a non. And we usually use this for solving problems and, doing some dynamic stuff. So how you initialize a variable? You do x equals 1. Python can be a very good calendar. You can do 1 plus 2, which is amazing. So let's say that I want to store the value of 1 plus 2. I can do this. I can write a variable, which I will define as a name a equals. So this is how you store a value in a variable. You do variable equals something else. So after that, we can just see that a has inside of it stored the value of 3. Let's move a little bit on the mathematical numerical operations you can do in Python. You can do addition, you can do subtraction, you can do divide, multiply, power, modulo, floor, division. And also we have PEMDAS, which is the precedent order of each operation here. So first of all, you do the operations inside the parentheses, then you do the exponent, then multiplication, division, addition, and subtraction in the end. So let's just try and do some of these operations in our Google Colaboratory. We have already, done some addition here. So let's do 1 minus 2. Shift enter to run this cell, and we got minus 1. Love it. 1 divided by 2. So this is the operation of division. 0.5. Love it. After this, we can try and multiply. You use the symbol to multiply, shift enter, 4. Amazing. And then we got modulo. What is modulo? So what modulo does is essentially, it tells us how many times you can divide. What it tells us is, if we divide the left value by the value on the right, what is the result of the division, meaning what is the number that is left? So if you divide 2 by 3, you cannot do it. So what it happens is that it cannot be divided and the rest of the number is 2. However, you can divide 3 by 3. So the resulting thing will be 0. If you want to divide 4 by 3, what happens is that the 3 can divide 4 one time, and the leftover will be the number of 1. After that, we also can, do the power operation. So let's say that we want to raise 4 in the power of 2. And boom, you've got 16. You use this double multiplication to say that, oh, I raised to the power. And also we got 3 with divided by 2. But this is called floor division. What it does is it divides the first number by 2 and computes the floor of the number of divisions. So if we did 3 divided by 2, we would get 1.5. Let's check it. So if we write 3 divided by 2, it's 1.5. But if you floor this, if you actually go and floor it, what it does, it's essentially rounds down to the value of 1. So 3 divided by 2 will be 1. And you also, another thing you can do is call a function called round. And we'll see later on what is a function and how to divide a function. But let's say that you input the value of 1.5 inside the function round. What the round does, it will round the number. And boom, you get a value of 2. So you can also use that. There are also a lot of other operators called comparison operators. These operators let you compare different variables or values with each other. So let's check it out a little. The comparison operators are not a lot different to the mathematical operators. The only change that happens is that mathematical operators return numbers. Comparison operators return Boolean values. But wait a minute, what is a Boolean value? A Boolean value, as we have said, is the true or false. So it's more of a logical value rather than a number value. So let's say that 1 is bigger than 2. What is this? Of course, false. 21 is bigger than 10. This is true. 21 equals, for equality, you want to do double equal value, because a single value here is the assignment value. You only use this equals to store information to a variable like this. If you want to check if alpha equals something, you do twice equals the value of 2. And this is false, of course, because the value of a is 1. If you check it against 2, it's of course false, because a is equal to 1. So what this means is essentially does this. Does 1 equal 2? False. Then you also have inequality, which is a is not equal to 2, which will be true. Okay, and there are a lot of other operations as stated here. Then we got logical operations, and or not. So let's say that we have two values, a and b. You can also think of them like variables. If a is equal to 0, and you can think of 0 like false, and b is 0, meaning false, then a and b, false and false, will equal false. If you do false equals true, so one denotes true, then again we are false. True and false equals false. The only way an AND operation ends up with true is that both values are true. The same does not happen for OR. It's like true or false equals true. False or true equals true. True and true equals true, but false or false equals false. And also we got the NOT operator, which turns everything upside down. Not false equals true. Not true equals false. So, okay, maybe you do not understand what I'm talking about, so let's check down the code. So let's say that A is true, B is false. What A and B will be from the things I've taught you? It will be false. However, what needs to happen for A and B to be true? For this one to be true? Very simple. You want B to be true. So if you go here and write B equals true, then A and B will equals true. For int to be true, you need both values to be true. Now let's try A or B. It will be of course true because you've got two true values. But if I say A equals false, B equals false, then A or B will be false because both of these values are false. However, if one of these or both of these are true, then A or B will be true. Let's check it out. Okay, so A equals false, B equals true, then A or B will be true. And then you can use not A. So not A will be true because here it was false. So not false equals true. Not B will be false because the value of B will be true here. So not B will be false. Okay, so we are done also with the logical operators. You see how much progress we have done in only 20 minutes? It's incredible. Let's say that A equals 20. You can write an if and say if A is bigger, for example, than 22. Just a very simple example. Is this true or false? So, is A bigger than 22? Of course, it's false. So, if I write some code inside here, and please, what you want to do for if statements is this procedure. You write if, you write your condition, and then you do the upside dots. Okay. Then, if you want to run code, what you need to do is press the tab button. You need to be indented with a single tab inside of the code here. So, if the condition is true, the print here will run, but you need to be indented. So, for example, if I want this to not run, I will use the print in the same indent in the same column with the if. And if I run this code, we will get an error because Python will tell us I expected an indent block after if. So what I want to do to not have this error is to press the tab button on my keyboard and boom, we're good to go. So bigger than 22. I call the print function that we've seen in the previous video, and I write a string inside of it that will output bigger than 22. Okay, so if I run this code with shift tab, will it print something? No, because A is smaller than 22. But if I change the value of A to 23, then boom, we will print out bigger than 22. Lovely stuff. Now, let's see other conditions. You can use something called if, which is a special case of if. If the first block doesn't get triggered, then we can add the second condition. If A is equal to 22, or let's say to 21, then you will print equals to 21. Again, you want to use the indent block for the print to trigger. However, elif should not be indented. It needs to be in the same column with if. So if A will equal 21, then this first condition will be false, so this won't run, but this condition will be true because A will be equal to 21 and this print will run. Amazing! It equals to 21. And also, if you want to have an escape case, you can use else. So for every other case where A is not bigger than 22 or A is not equal to 21, what is going to happen is that this print will get triggered. So we'll, use just an arbitrary string. So if I say that A is equal to 20, this will be false, this will be false, but this will always be true if this case and this case is not correct. So boom, you will see that the print will use this. So let's see a more complicated example of if-else statements. So we can take this example, we can do a copy paste, and we go here and put A equals 20. And now I want to put a nested if-else statement in the first if. So if A is actually bigger than 30, which is a special case of this, so when A will be bigger than 22, it will say bigger than 22. But if also A is bigger than 30, then I want to use another print. So you see that we indent, we put this inside of this if by using the tab here, and we say bigger than 30. Boom. If we run this, again we get the dots, but if we do here, we put 31 to the value of A, then we will get two prints, bigger than 22, bigger than 30. Great, so this is your introduction to the nested ifs as well. Please go and play around a little bit with all of that stuff. It's really interesting, and if statements are going to be used nearly always on your code, so you better get accustomed to it. So let's talk a little bit more about the strings, or else called sequences. You can do a lot of operations with strings, and they're really, really important to understand. First of all, you can concatenate the input. You can multiply it, you can index specific parts of a string, or let's say a text or a sequence. You can use slicing, so you can select a specific part of the string, and you can also iterate using a for loop inside a string. However, I have not taught you for loops and in general loops till now, but it's also one of the next stuffs that we're gonna be learning. So let's go and check it out a little bit. Let's see that, for example, we've got b equals hello, and we also got c equals world. Okay, let's say that we've got these two strings. What can we do with those two strings? As you've seen, we can do a concatenation. We can add these two strings. But wait a minute, this is text messages, it's not numeric values. How you can add them? Just run this code and see the example. Hello world. Okay, let's put a space here to make it more beautiful. Hello world, this is the result of the concatenation. You can also multiply something. You can do b multiplied by 4, so we get the value of hello 4 times. Nice. You can also get a specific part of the string by using these brackets and the positioning. So the positioning inside Python starts from the number 0. So if you put b0, then you will get the value age, because the first position which you index with 0 is age inside of b. b1 will be e, for example. And if you want to get the first two positions, you can do b brackets 1, boom. You can do this, 0 to 2. What I need you to understand here is that we want to index from the 0 position the two next positions. So this is equal to b0 plus b1. Okay, it's a little bit strange because what you see here is 2, so you expect also L to be in here, but this is not the case. What you say is that you start from the first position, you add this and the next one. You go till 2, but you do not include 2. If you wanted to include 2, you do b3. So this is how it works. Everything here is just one step minus what you use in reality. The first position is the 0 position. The second position is the first position in the coding perspective. Okay, so the next step is to do b minus c. Can you do that? Of course not. How are you going to remove one string from another? You can just you cannot do that in a logical way. However, you can do b.remove the value of L. Okay, you cannot do that. Okay, so we've seen also how we can index inside the string, how we can multiply, concatenate, and slice. I will keep this for loop for later on when we, start with the for loops. Now you will ask, why did you write A here? So the idea is that on Google Colab, if you write a single variable or something alone, what it does, it calls a function called print with the variable inside of it. So the print, what it does, it's outputs to the user the value inside these two brackets, inside these two parentheses. So it will show us the value of A. Very simple, and you just learn what print does. So, really interesting. Let's do something interesting. Hello, friend. Let's print to the user the string hello friend. So what you want to do is use this double marks and write text inside of it. Let's run this. Hello, friend. And I just forgot. How can you run the Google Colab code? What you need to do is press this button to run it, or else you can use Shift Enter. But in order to use Shift Enter, you need to select the box you want to run. Just single click and Shift Enter. Boom, hello friend. So this is how you run some code on Google Colab. Pretty simple, right? Okay, let me show you something. Let's say that you've got an integer. Okay, let's say that you have an integer which is a equals 1. Let's say that you want to change this into a string. What you do is call the function str and put inside the parentheses the variable name, and boom. What this does, it returns the let's say the value of A like a string. So let's say that you want to print a string here. Okay, let's say that you want to print the value of A. Print the value of A. If you go here and do addition and you put A here, it will tell you that you cannot concatenate string with an integer. So what you do here is do string A. So you change A into a string, and boom, you concatenated two strings so the print can work. Another way to print stuff like that is what I've called, I don't know, you actually put the keyword def before the string, you do a print, the value of A, and here you use this, I don't know how they're called, curly braces, and you put the value of A here, and you don't need to turn it into a string. It does that automatically. So it's equivalent, but you need to use the value of F here, so you can use this notation inside the print. You can also get input from a user by inputting the value input. So the function input allows you to get some input from the keyboard of the user and store it into a function. So let's say that we run this code, okay, and we specify a string that we want the user to see. So if we run this, we get to see hello, input your name. So I will input my name as Aero, and boom. If you print the value of A, it will be the input that we've given, which is Aero. So this is how you do input in Python. Very, very simple. You can also get input from files like CSV and other stuff, but this is something that we're going to cover on the advanced course. This is how you can do outputs in Python with all the print messages that we've seen, like before. And yeah, that's pretty much it. Okay, so loops in Python are very important. You have two ways you can do for loops. You can either loop using a for operation or a while operation. And right now we're going to see how these two operations work. We're going to do some very simple examples because it's an introductory course and I just want to show you the basics. We will probably go a little bit deeper into the advanced course that I'm going to be releasing really, really soon. So subscribe to the YouTube channel and in general, stay tuned. So how you define a for loop? For You need a for, you need this upside down notation, you need a condition here, and then you want to indent using a tab and write some code here. So this is how a for loop looks like. Okay, so let's keep this loop here and let's write. Let's say that we want to print numbers from 1 to 3. What we do is do for I, a simple variable name, in range 0.3, and you call print I. Let's run this code. So what this code does, it's pretty simple. It's pretty simple. What this code does, it prints the values from 0 to 2. Again, everything in Python starts from the 0 position and tends 1 position before. So what the range does, let's see, if you hover over the range value on the collab, it will print out exactly what it does. You start from 0, because we specified the start will be equal to 0, and you then want to stop at the value of 3. But it's an open ending, so you do not include the value of 3. So what we do is we want for every I which is in range, what range does, let's see here. If you call range and wrap it around the function called string, you can get the values of range. So this range will be 1, 0, 1, and 2. These are the values. So for I in this range, meaning 0, 1, 2, we want to print it out. And we, of course, print it out 0, 1, 2. Beautiful stuff. So this is how you do a very simple for loop. You can also do for I in and write here the string hello. And you can print each of the elements, characters, let's say, of hello. So if I run this code, check out age, E-L-L-O. So what print actually does at this point, it prints I, adds a new line operator, which you can see like this like the new line operator. So it changes line, and then prints I, adds a new line, prints I, adds a new line, prints I, adds a new line, and boom, you've got hello like that. So this is how you can loop over a string or a sequence. There is also another operation for looping, which is while. We usually do not use while because you can end up with infinite loops. So what while does, it's pretty similar. Let's say that we want n to equal 0. And then we use while n is smaller than a value, let's say 5. And we put the upside down dots. What we want to do is while n is smaller than 5, we want to print n. Okay, but there is a problem here. If we do not change the value of n will always be smaller than 5, because the value of n will always be 0. So this operation here will always be true, and we will always be printing n. So this will lead to an infinite loop. So what you do here is do n equals n plus 1, plus 2, plus 3, whatever you want. And there is also another operation that I want to show you. Instead of writing all of this stuff, you can do plus equals n, plus equals 1, which what it does, it adds to the current value of n the value of 1. So these two are identical, and you save this extra code here. So let's use that. So we print the values 0, 1, 2, 3, 4. Incredible. This is a while loop. Lovely loop. There are also other ways you can break a while. For example, you may want while true. You want always to keep looping around this code. And let's say that each time you print wow, the value of wow, and you've got also value x equals 1. So let's say that we add this condition here and we call break. What operation break does, it is very, very simple. What break does, it stops the loop. It stops the while true. It closes this loop. It's essentially what we've done here. When n became equal to 5, boom, the loop stopped. So break, what it does, it stops the loop, which is very, very important to know. So what you do here is x equals to 1. Okay, so we start off with x equals to 1, and we forever loop around until we find x equals to 1, where we stop the loop. So what do you expect from this while loop to do? Of course, it does one loop, then x becomes 1, and we stop the loop. So it will print once the value of wow. Oh, and it did it 2 times. Why? So the first time it prints wow, the value of x is equal to 1, so break is not called, then x becomes 1. But when you go back into the loop, the first thing that you want to be doing is print wow. And then, after printing wow for the second time, this value will be called the if x equals to 1. So the break happens after the second print. Really interesting stuff. Okay. So you may have seen me write something like this. You've seen me write something like this, and you say, but wait, this is not Python code. Yeah, Python has something called comments. Comments are really useful to put some description near your code to understand what it does. So there are 2 ways to write comments in Python. You can use this cell, which is the 1-line comment, because if you change line and write something, boom, you see that this is not a comment. So you can use this 1-line comment or you can use the triple notation here to add multi-line comments. So this is a multi-line comment. And you can see here inside those values that you can write multiple values. Amazing. So, boom. So the next topic that we're gonna be discussing is the data types inside Python. I specifically believe that there are 4 very basic built-in data types: dictionaries, sets, lists, and tuples. So tuples actually allow you to use different data types and store them inside the tuple. So this is really useful. And what you can do is add tuples to each other and also use equality between tuples. Then you've got lists, but the difference between tuple and list is that tuples are immutable. They cannot change in place. However, lists can change in place. And they also have a lot of other operations that are really like. Finally, we've got dictionaries. Dictionaries use a key-value pair. They look a little bit like hash tables. And they are very, very good for recovering information. You can use .keys to find the keys of the dictionary. And you can also use the brackets to access the value of a key, or also use .get to access the value of a key, but if the key doesn't exist, you get the default value that you specify. We will see in code exactly how each of these work. And you also got sets which only contain unique elements and no duplicates. So, okay, let's specify a tuple. To specify a tuple, what you want to do is use the parentheses and the equal value. So, boom, this is a tuple. If we use the function that we've learned in the previous videos, which is the type A, we can see the value, the type of the function of the variable A, which is a tuple. So let's say that we have B 2.3.4. What is B? Of course, it's a tuple, and we can do A plus B. What the result is going to be? Oh, this was entirely unexpected. It added the two tuples inside one single tuple. Interesting. So, let's say that we got this. Is A plus B equal to this? Let's check it out. I'm really interested into finding out with you guys because tuples is a data type that I rarely use. Oh, and it's true, actually, A plus B is equals to this function, to this tuple. Amazing stuff. So, okay, this is how you use tuples, and you also can access a value of a tuple by using the bracket. So A1 will be the value of 2, because you see the tuple here. The first position is the position you can index by 0. So A0 will be 1, A1 will be 2, let's write it out, and A2 will be 3. A2 will be 3. Boom, you're good to go. Let's move on to lists. Lists are an amazing data type. Let's initialize a list. You can do that by using k equals that or equals list and parentheses, empty. You can also initialize a list with values inside of it. So you can do list, let's see. Okay, so a list expects one argument. So if you do this, again, it's incorrect. You usually initialize lists with brackets because this list is used to convert a different data type to a list. So for example, you can do B list and you can put like this tuple inside of it. So let's see. Will this run? Yes. So what it's gonna be? How is gonna be B? So it will be a list for its value of the tuple, 2.3.4. Okay, so let's say that we want to extend A with B. So if we use a.extend with the value of B and call A, we can see that A from 1.2.3 became 1.2.3, and also it was extended with an iteratable, with another list or a tuple or whatever. So this iteratable included the values of 2.3.4, and these were added in place to A. However, keep in mind that if you use another value, which is append, and append B, the result will be entirely different. Why? Let's see. If you use a.append B, what you do is essentially append the list as is. You do not append the elements of B, but you append the B as a data type. So right now we've got some scalars in our list, and we also got in the last position of the list another list. So we've got nested lists. How you can handle and use nested lists is outside the scope of this course, so I'm not gonna go into it. There are also a lot of other operations that you can use with lists, and I really do not want to really do all of them. But for example, let's see really quickly. You can do a.sort and then call A again. And what a.sort does, it sorts the list in ascending order in place. In place meaning it changes the order inside of the original object. There are other functions that are called and return a new object rather than change the object itself. You can also do a for loop with list, as we've seen before with the range iteratable function. So what you can do is do for I in A, you want to print each value of the list here. So what this gonna do is print each element with a new line. 1, 2, 3, 4, 3, 3, what does it prints each element of the list. And you can do a lot of stuff here. You can actually do if statements to find specific parts of a list that you want to use, etc., etc. And there are a lot of other, functions here. So you can also try them. I have them in the PDF. So let's go to the dictionaries, which is arguably one of the best data types in Python. You can initialize a dictionary by using these two things. Again, it's the same thing with, let's say, Python. So A will be a dictionary here in both cases. So I'm not really sure if A will be a dictionary here. Yes, it will be a dictionary. So how can you add elements to a dictionary? You specify a key and you specify a value. For example, I want the key to be called key. So if I call the A key here, we will take the value of 1. Boom, this is amazing. I can also get the value of a key by doing A, which is the dictionary, dot get, and get the key. So the value we are going to get is 1. However, if I try and access a key which is not existent inside of the dictionary, I'm going to get an error. But there's some error handling here. You can use the get function, and if there is not this key inside, you can use a default value. So okay, try to find the key named 1 by using a string. If you don't find it, okay, return me the default value of 1. So boom, here we do not get an error, and we get the value of 1, which is like a placeholder. It's for error handling, really, really good. So this is a very, 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 very quick introduction to dictionaries. I really do not have time to spend on this because I need to show you graphs to really explain everything into very, very much detail. But I think this is outside the scope of this very introductory tutorial. We'll do more of dictionaries in the advanced tutorial that is going to be coming soon. And in general, we will use all these data types a lot more heavily because we are also going to do a little bit of data science. So we'll learn about all of these things in more detail there. And we also got a set. So, okay, let's say that we specify a set here. Okay, so we can add here the value of 1. You can add 2. And you can see here that we've got a set with values 1.2. If I want to add again 1, what is going to happen? A set only contains unique elements, so nothing is added because 1 is already inside the set. So this is all about the other data types, just a very short, very quick introduction. I may really have messed up your brain with all that stuff, but we're gonna see it in more detail later on. For now, you do not need to know a lot about this. I just show you that this exists. You can read more on your own, try some stuff. I have nearly all of the operations you can do with this, and you can play around with them. Play on your own, guys. It's really important for you to learn code. You need to try stuff on your own. You need to, get a little messy. Write some Google searches. It's part of the process. Trust the process and enjoy the process. So let's talk about the function and classes. How you define the function, you call what we call def. This is how you define the function. You define a function by calling def name and using parentheses. Inside of the parentheses, you can use something that it's called arguments. arg1, arg2. What arguments are used for is to pass values inside the function. So let's say that we want to do addition. So we do arg1, arg2 and print and store all of this into a result variable. If we print the result inside of the function, we're gonna see the addition. So okay, this is how you define a function. You press Shift Enter and boom, you're good to go. Again, don't forget, when you call this upside down dots, you need to do an indent after that. So let's call the name with the arguments or the values 1.2. And we get printed the value of 3. This is absolutely amazing. Let's store the resulting value of a equals name 1.2. let's say the value of a. A does not have any value. Why? Because this function is not a data type. It's getting called, and that's all that happens. If you want to return the result of addition, what you need to do is put here the keyword return and return this addition. Remove the result here, and boom. Let's go and do this again. We see here that there is no print. However, the value of a will have stored inside of it the addition arg1 and arg2. What happens here is that arg1 is equal to 1 and arg2 is equal to 2. Because you can see that arg1 will take the value of 1, arg2 will take the value of 2. If I come here and try to print the value of arg1, then boom, arg1 is not defined, because everything that happens after this parenthesis for the function is done inside the function. We cannot see it, we cannot test it, we cannot access it. It's outside the function. So if I write a3 equals 2, and I try to access a3 here, we will get again an error, because a3 only happens inside the function. I don't want to go into details why this happens, because it needs for you to understand a lot of computer science, how memory works, how function calls work. It will take like 10 hours for me to explain it to you. But what you need to know is what happens inside the function happens only inside the function. It's like what happens in Ibiza stays in Ibiza. Think of it like that. Then we've got a class. So let's create a class for a calculator, a very simple calculator. So to define a class, what you do is write the keyword class, the name of the class, and you do the upside dots. Again, I do not remember how these are called in English. Then you can use a function, you can define a function which is called init with keyword self. What is happening here? Okay, so the init is one of the built-in functions that you use usually for a class. And what happens inside init is that it initializes the class with some specific values. The self keyword is a built-in, let's say, keyword that allows you to access the in-store memory of a class. So to store something inside the class, what you do is self dot the name of the variable you want and let's say 0. So this is how you specify a variable inside a function. This will be kept and you can access it outside of the function. So what I've done here is essentially I initialized a variable current equals to 1. So let's check out this very simple example. So let's create a variable that is gonna be storing the object of the class. So what you need to do for you to create and access the class is you need to call the name of the class and 2 parentheses. So what this does is essentially it calls init and creates an object. So if you run this, okay, I have not run this code. Okay, so what you've done here is create an instance of this class and we call it an object. You can access current by doing a.current, and the value of a.current is 0. So you get the value of current by doing a.current. Pretty stuff. After that, you can do something really interesting. You can add another function here. Again, you call the self, so you can access this value and every other value that has self.something. And also you want to pass in another argument, which is the amount, how much you want to add to, let's say, the current value. So what you do is current plus equals, we've seen what this means in a previous tutorial, the amount. Okay, so what essentially add does, it takes an integer or a float here and adds it to current. And we can also use another function called getCurrent self, which we're gonna be asking for it to return the self.current. So this method can be called a set method because it sets, or let's say changes a value of our object, and this is a get method which returns a value of our object. So here, instead of using k.current, let's run this code first, run it again. So we change the class inside the memory. We recreate this object with a new class, and what you can do here is instead of accessing this value specifically, you can do get current, and the result will be the same. Then you can do a.add, and you add the value of 1. So when you call a.getCurrent again, the value will be 1 because we added 1 to the current. Now a question will be, why is not self argument passed here? So the self argument is passed without you needing to do anything, because when you call a dot, essentially a will take the value of self. So what you do is essentially you do a dot 1. This is like this, but this is how Python handles it on itself. So the self object will be the a, and you won't have to do this. Actually, this, you cannot even run this. It will throw an error. So again, think of self like something you put on the definition of a class so you can access this object, and then you only care about this argument, the next arguments. You do not need to do like this. Okay, you just need to do a dot add and the other arguments. So this is also a very small introduction to classes. We've built a very simple calculator just to give you some intuition about classes work. You can see the type of a variable by calling the function type and putting inside the parentheses the variable for which you want to learn the type. Let's run this. Type a equals boolean. Lovely. If we say a equals 1 and again use type a, then it will tell us that the value of a is integer. This is lovely, this is amazing, this is absolutely great. And one of the things that I have not shown you, or you may have understood, is that we can do all of these operations by using variables. So let's say that a equals 1, b equals 2. If I do b minus a, we will get the value of 1, because a variable is just the representation of the stored information. So essentially what this does is 2 minus 1. Okay, so if we use variables from now on instead of values, you can understand that it's just a value stored inside of it. It's nothing different. We're going to be seeing function and classes, and I'm just going to show to you two very simple examples in not of a lot of details, but the main idea is that you use class and functions to do reusability. Classes can keep a lot of information inside something that it's called objects, and functions can be used to do specific operations again and again, irrespective of the input. But again, more about this will be shown in the advanced course. And now, let me preach a little bit about the advanced course, where we're going to be seeing classes in depth, functions in depth. We're going to be seeing lambda functions, reading and writing files, how to use exceptions and do error handling, how to use assertion to do defensive programming, and feeling a little bit more safe with the stuff you write and save a lot of time doing debugging. You are going to be using external libraries like NumPy, data frames, and we're also be doing some very simple machine learning and data science, which is lovely stuff because there will be coming another course which will be visualizations, data science, feature selection, Bayesian optimization, predictive modeling. We're gonna be diving into machine learning, and later on we're gonna be diving into deep learning. This is gonna be an amazing journey that I want you to do together with me, because I'm gonna be teaching everything I know and pretty much show you everything you need to know about machine learning, data science, and also after that we're going to be diving into deep learning, large models, language processing, images, audio. We're going to even be doing video. So this is a journey that just starts with Python and will finish up with the most complex state-of-the-art stuff. So stay tuned, subscribe to the YouTube, follow the Udemy channel, see these tutorials, start building, start learning, because the journey is gonna be amazing.